All right, starting off the new chapter, Chapter 4, Lesson 4.1, Radians and Degree Measure. Okay, so you've worked with measuring lengths in the past in different ways. You can measure it in feet, or you can measure it in meters or yards. Okay, so the same applies to angles. There's different ways to measure angles. Degree measurements are what you are very familiar with already, and radians is a new concept now. Introducing radians for trigonometry. All right, now a radian is the measure of a central angle, theta, that is the ratio of the intercepted arc to the radius. Okay, that's a lot of terminology there. Let's break it down. So here we're starting on a coordinate grid. And on the x-axis, the positive portion, you're going to start with a segment here. And that's known as your initial side. Then you're going to rotate that segment. Okay, you're just going to rotate it. All right. And we'll stop here. Okay, and we get this arc. All right, this arc here is known as the intercepted arc. It's the arc formed by the red segment and the blue segment. Now the angle that we get, that's known as theta. All right, it sort of looks like a zero with a line through it. All right, so if we take the intercepted arc and we divide by the radius, that gives us our theta. So for example, here, my intercepted arc is r. It's the same length as the radius. So that right there is 1 radian. If I move 2 arcs of length r, then that's 2 radians. All right, once again, this is r right here. These segment lengths are r. Okay, so going all the way around, we have a little more than 6 radians. All right, let's try to understand this from a different angle. 1 revolution. All right, 1 revolution means we go all the way around the circle. All right, well, we know that's 360 degrees. All right, now moving into a new territory, and it's very important to get familiar with these conversions because from this point on, you'll be using them all over the place. So 360 degrees is equal to 2 pi radians, or in other words, 6.28 radians. Well, pi is what? 3.14, right? So that's where 6.28 radians comes from. And if you look at this diagram, if you go all the way around, we have 2 radians, 3 radians, 4 radians, 5 radians, 6 radians, and a little more. Altogether, it's 6.28 radians. Typically, you won't plug in 3.14 for pi. All right, you'll just leave your answer in terms of pi. All right, now half a revolution, half a circle, that's 180 degrees. All right, in other words, that's pi radians. All right, get very familiar with these conversions. You're going to use them very often. All right, just like 12 inches is 1 foot, okay, 360 degrees is 2 pi radians. So you should get very familiar with it. All right, and then we'll do one more here. 1/4 of a revolution, or a quarter of a turn, that's 90 degrees, right? And that's pi over 2 radians. Okay, now let's go over a couple examples that help us develop familiarity with using radians. All right, determine the quadrant in which each angle lies. The angle measure is given in radians. Okay, here we have 11 over 8 pi. Well, I know that this is pi over 2, or half pi radians. All right, and if I want to convert this to eighths, I'm just going to multiply this by 4. So I have 4 over 8 pi. Okay, I know that this over here is pi radians. All right, so I can multiply top and bottom by 8. So I get 8 over 8 pi radians. Now where would 11 over 8 pi radians be? Okay, well here, let's go back to what we have here. Just breaking it into pieces. That's 4 over 8 pi radians. If I cut it in half, that's what? 2 over 8 pi radians. And if I cut that in half, that's 1 over 8 pi radians, or pi over 8 radians. So we have 1 over 8, 2 over 8, go in the middle there. I have 3 over 8 pi radians. Then I have 4 over 8. Then I have Oops, don't want to move that. Oh man, what's going on here? 5 pi over 8 radians. Then I have 6 pi over 8 radians. Then I have 7 pi over 8 radians. Okay, if you're having any issues with this right now, make sure to ask for help. Then I just continue. I have 9 pi over 8 radians, 10 pi over 8 radians. Then right here is where I want to end up. That's 11 over 8 pi radians. Okay? So that's where my terminal side, this is my terminal side. Once I rotate, I started here, and I rotate 1/8, 2/8, 3/8, 4/8, 5/8, 6/8, 7/8, 8/8, 9/8, 10/8, 11/8. And this is my answer in green. Okay, that's where my terminal side ends up. And what quadrant are we in? We're in quadrant 3. For the next one, 2/3 pi. Okay, well this is half pi, or pi over 2. This is just pi. And I'm working with thirds, so I want to multiply top and bottom here by 3. So 3 pi over 3. Okay, now I'm going to divide this half of a circle into 3 parts because I'm working with thirds. So that would be about right. I have 1/3 pi, then I have 2/3 pi. Okay, then I have 3/3 pi. So this is my terminal side. This is where I end up. And what quadrant am I in? I'm in quadrant 2. All right, here's another little strategy you could use. If radians are confusing you, you could always convert it to degrees to make better sense of it. So here I have 2 pi over 3, or 2 over 3 times pi radians. Okay, if I want to convert this into degrees, you had a couple conversions before. You had 360 is equal to 2 pi, you had 180 is equal to pi. Typically, you'll use 180. All right, so I have 180 on top, that's for degrees, and I have pi radians on the bottom. All right, this is my converting fraction right here. All right, so it's just like as if you were in chemistry, you're using converting fractions. All right, now this allows me to convert this into degrees. So the pi's cancel out. 3 goes into 180. 60 times. I have 2 times 60 on top. That's 120 degrees. All right, so if you rotate, that's 90 degrees, and 30 more, that's 120. So that seems about right. So if you're not very sure where you're going with radians, just convert it into degrees, and that should make it much easier. All right, going on to example. Sketch each angle in standard position. Okay, this could be a little tricky because there's a negative thrown in front. So instead of going counterclockwise to start with, you're going to move clockwise instead. All right, so instead of having pi over 2 to start with here, I'm going to go backwards, and this will be negative pi over 2. And since I'm working with force, I want to convert this into force. I have negative 2 over 4 pi. Okay, well if I split this in half here, I have negative 1/4 pi. All right, then I have negative 3/4 pi. You can see the pieces that it breaks up into now. Negative 4/4 pi, negative 5/4 pi, negative 6/4 pi, and negative 7/4 pi. All right, that's where I end up. So I started here, and I rotated all the way around negative 7/4 pi radians. All right, and that's all we're doing. We're just sketching the angle, going all the way around. All right, and you could use this little loop here as well with the arrow to indicate the angle or the rotation. All right, now for 5/2 pi, that's pretty easy. I know that this is pi over 2. I know that this is pi, or in other words, 2 pi over 2. and this would be 3 pi over 2, because you're just adding pi over 2 every quarter of a circle or quarter of a rotation. Then I have 4 pi over 2, and I'm going to keep going around, right? I'm going around, I'm still going. Another pi over 2 gives me 5 pi over 2. Alright, so these actually overlap with each other. You could keep going around and around. Alright, so this is where I end up for my terminal side. So starting from here, going around, you can make this little looping arrow here, and that's where I end up. Alright, going on to the next example. Okay, for example 3, it says determine two coterminal angles. Coterminal means where the angles overlap. All right, one positive and one negative for each angle. Give your answer in radians. Okay, so we started off rotating and we ended up here. This is my terminal side. Now, how do you find coterminal angles? All right, it tells me that I rotated 7 over 6 pi radians. All right, coterminal means they overlap. So in order to rotate from here and get back to where I started, what does your rotation need to be in radians? Well, that's 360 degrees, but we're working with radians, so that's 2 pi radians. I have to add 2 pi radians to get back to where I started. All right, it says it wants one negative answer as well. So I have 7 pi over 6, and I could go backwards. All right, and subtract 360 degrees, but we're working with radians here, so I'm going to subtract 2 pi radians. All right, so this is our simple setup. We just need to simplify these two problems, or these two expressions. All right, so I have 7 pi over 6 plus 12 pi over 6. All right, finding a common denominator. So I end up with 19 pi over 6. That's one answer. Then I have 7 pi over 6 minus 12 pi over 6. And that gives me negative 5 pi over 6 radians. Okay, that's example 3. Going on to example 4. Find, if possible, the complement and supplement of the angle. All right, this goes back to geometry. Complement means two angles that add up to 90 degrees, but we're working with radians here, so that would be pi over 2 radians. Okay, and the supplement. Supplement means the angles add up to 180 degrees. In this case, they need to add up to pi radians. All right, so to figure out the complement of pi over 12, I take simply pi over 2 and I subtract pi over 12. So I end up with 6 pi over 12 minus pi over 12, and that gives me 5 pi over 12. That's the complement. All right, once again, why did I take pi over 2? That's the same thing as 90 degrees. All right, so that gives me the angle I need. So when I add them together, I get pi over 2. If you add these two together, you get pi over 2. All right, the next one I have a supplement. All right, so I'm going to take, in this case, I'm going to take pi, and I'm going to subtract pi over 12. All right, so I get 12 pi over 12 minus pi over 12. All right, and that gives me 11 pi over 12. All right, and that's the supplement. So if I add these two together, I'll just end up with pi. All right, that shows they're supplementary. All right, going on to the next example. All right, this is really simple. This is simply just doing conversions. So I have 315 degrees. All right, I'm going to convert this into radians. So we have a couple converting fractions. The most simple one to use is 180 degrees is equal to pi radians. All right, these two are equal to each other. All right, so I have degrees on top, degrees on bottom, they cancel out. Then I could divide 15 into both of these numbers. 15 goes into 180. 12 times. And 15 goes into 315. 21 times. I could still divide these by 3, so I get 4 and 7. So I end up with 7 pi over 4 radians. All right, and you don't have to put radians at the end. It's just implied by the form that you have it in, since we're working with angle measurements. All right, example 6, same deal as before. I have negative 7 pi over 12. All right, this is radians. All right, so on the bottom here, I'm going to use radians this time because I need them to cancel out and use degrees on top. All right, so radians cancel out, pi's cancel out. 12 goes into 12 once. 12 goes into 180. How many times? 15 times. And then I have 7 times 15, which is 105. All right, so that's degrees. And don't forget the negative. All right, it's just simple conversions here. All right, you're going to do this very often in the future. All right, here we have a couple new formulas. All right, these you used back in geometry, but you weren't working with radians back then, so they're a little different than they were in geometry because they're incorporating the radian concept in the formulas. All right, so arc length formula is S, the arc length, is equal to the radius times theta. And then here we have the area of a sector. All right, so just to be clear here, this length here is what you could refer to as the arc length. Okay, but now I'm working with sector. That's like a piece of a pie. Okay, so it's the area. So sector is the area of the piece of pie. All right, and pretty simple formulas to apply. Example 7, find the area of the sector of the circle with the radius r and central angle theta. All right, so find the area. It's half. The radius is 12, and theta is pi over 4. Okay, so simplifying this, I get half times 144. Make sure to square here before you cancel anything out. A lot of students goof that part up. All right, so I have pi over 4. And then I'm going to simplify. Half of 144 is 72 times pi over 4. And simplify that, I get 18 pi. All right, so area is equal to 18 pi. And since I'm working with area, it's going to be square units. And I'm working with millimeters. So millimeters squared. And let me clean this part up a little bit. That's a pi. Alrighty. On to the next concept and the last one. Okay, DMS, degrees, minutes, seconds. What is this all about? Well, you're familiar with degrees, but what is minutes and what is seconds? Okay, so minutes and seconds are finer units of measurement for an angle. So, for example, say this was 1 degree. That's 1 degree. All right, well, I could divide 1 degree into 60 minutes. It's just like time. All right, so I could have like 60 lines here. All right, a bunch of lines, 60 lines. All right, every gap would represent 1 minute. All right, so this right here in the green, you could say, is 1 minute. All right, and the apostrophe, one of them, indicates minutes. Now you could take that 1 minute, all right, that 1 minute, and you could divide it into 60 pieces. 60 pieces. All right, and every one of those units, all right, I'm trying to magnify here, that would represent 1 second. Okay, so you could take a degree and break it down into 60 minutes, and you could take a minute and break it down into 60 seconds. So once again, this is for ultra fine angle measurements. All right, example 8, convert each angle measure to decimal degree form. Okay, how exactly does this work here? All right, well, we have 245 degrees. All right, now, then I have minutes here. Now I could convert the minutes into decimal form. So all you have to do is take 10 and divide it by, well, how many minutes are there in a degree? 60. All right, converting that to a decimal, you could use a calculator, is 0.167. So you just attach that or replace the 10 minutes with 0.167. So I have 245.167 degrees. All right, really simple once you get the hang of it. All right, for the next one, I'm going to take the 16 here and divide that by 60. It's just like what we did before. But what do you do with the 20? Okay, now the 20, you're not going to divide it by 60. You're not going to divide it by 360. You're going to divide it by 3,600. Okay, now why 3,600? Okay, well, let's think about this for a moment. Watch what I'm doing here. How many minutes in 1 degree? There are 60 minutes in 1 degree, right? All right, well, here's 1 minute. Well, I took 1 minute and I broke that into what? 60 seconds. Okay, so all you're doing is 60 times 60. That's 3,600. That's how many seconds there are in a degree. That's how you come up with the correct decimal. So from here we get 0.056. And to come up with your decimal equivalent, you just add these two together and tack them on to the 408. So I get negative 408.2756 degrees. Done. All right, so I went from DMS form, degrees, minutes, seconds form, to decimal form. All right, now for example 9, convert each angle measure to degrees, minutes, seconds form. All right, this is what you're going to do. So the 345 is there. That's your whole number. The decimal is what you're concerned about for the minutes and the seconds. So you take 0.12 and you multiply it by 60. All right, so that's going to give you your minutes. So I get 7.2. All right, now this is a very important idea here. The whole number, that represents your minutes. The 0.2 that's left over, you're going to use that to obtain your seconds. All right, so now I take 0.2 and I multiply that also by 60 because there's 60 seconds in a minute. So now I get 12. And this represents my seconds. Okay, so now I'm going to tack this on. I have negative 345, that's degrees. Then I have my 7 minutes. And then I have my 12 seconds. And we're done. It's in DMS form now, degrees, minutes, seconds. All right, last one. I'm going to take this decimal here. So I have 0.7865, multiply it by 60, and I get 47.19. The whole number represents your minutes. I take the 0.19 and do what to it? Multiply it by 60 once again, and I get 11.4. Now I know I end up with a decimal still at the end, but there's nothing else we could do at this point. We're not going to get into finer units of measurement. So you're going to use that decimal in your answer. So I have 0 degrees, because I start off with my whole number here just being 0. Then I have 47 minutes. Then what do I have left over at the end? 11.4 seconds, double apostrophe, or it's like quotation marks for seconds. All right, so I know we just covered a lot of material. There's a lot of different concepts here. If you have any questions, make sure to ask. This chapter is loaded with new material. If you fall behind a little bit, it's just going to start building more and more, and it's going to become overwhelming. Don't allow that to happen to yourself. Ask me for help. All right. Begin the assignment at the bottom of the web page.